Now we're going to practice our learning skills on substitution elimination again with a couple trickier problems. So for example 3, I'm already telling you that this is going to be inconsistent, but let's see how we can spot this. Now, first thing you want to do, of course, because I'm not going to tell you whether a solution's, inconsistent or a system is inconsistent on the test. So you're going to have to be able to look at those and know, what do I do? What do I try? So if I ask you to solve this, do you see how none of the variables are 1 in front of them? None of them are blank or naked variables, if you will. They all have numbers in front. That's usually a sign that elimination is the better way here. So I'm going to try elimination. Bear with me because I already started this problem and then my computer died. So, all right, so I've got 4 times 3. Now, what in the world am I doing here? Well, there's my top equation. There's my bottom equation, right? And then what I saw was that I have 3 here and negative 12 here. So I want to make it so that it's positive 12 and negative 12. So I figured if I multiply by 4, I'm going to get positive 12. So 12x minus 8y is equal to 28. And then the bottom equation just sits there. All right. Okay, well, when I add them up, this is going to go away, right? Because 12x, take away 12x, makes 0, right? There we go. So over there it's gone. But then negative 8y plus 8y is also gone because negative 8y add 8y also makes 0. So I'm left on the left-hand side with 0. On the right-hand side, I've got equals 41. Okay, this is impossible, right? Does everybody see that, hopefully, right? 0 is not equal to 41, right? This is impossible. Oopsie. Impossible. 0 is not equal 41, right? That's a sign that this is an inconsistent system. If you end up with a phrase at the end, so the answer is there's no solution. It's 0 with a slash through it. The null set, right? So there's no solution. There's your answer. Right? And then for your learning purposes, you'll want to say to yourself, okay, inconsistent system means there's no answer, or no solution, excuse me. Okay, now how am I going to spot that? If you end up with a phrase, if you end up with an impossible statement and no variables, like here all the x's and y's disappeared, that's an inconsistent system with no solution. Which you could say no solution, by the way. You don't have to do the 0 with a slash through it. You can just say the words no solution if you like. Like that. That'll work as well. All right? That's what it says right here. If you have an inconsistent system, you're going to end up with a false statement. That's what I'm talking about here. Some statement that has no variables in it but is impossible. If that's the case, you have an empty set solution, a no solution, null set solution. It doesn't have a solution. All right, what about dependent? When you look at this one, hopefully you spot that you have a plain variable. Do you see the x equals by itself right there? This is ripe for substitution. So we are going to substitute. It was negative 5x plus 20y. Let me move it over so you can see. Plus 20y equals 25. And then what I'm going to do is instead of writing the 5x, I'm going to put 4y minus 5 because my equation is already solved for y on the bottom one. Right? So instead of x, I write 4y minus 5. So that was my bottom equation. See how x is already solved for down there? You're going to substitute it into that top equation, that substitution method. And then you just solve it. You go, okay, that's negative 20y plus 25 plus 20y equals 25. Now here's an issue again. Negative 20y plus 20y disappears, right? And you're left with 25 equals 25. Okay, but that's always true, right? As opposed to the last one, which is never true, this one's always true. Right? 25 is 25. That's kind of the definition. So put that always true. 25 equals 25 at all times, right? That's a dependent system. There we go. It's a dependent system, so the solution is all the points on that line. And I didn't have to say that line. I could have said the other one. Just pick one of the equations. But every point on that line is a solution because these two lines are actually the same line, right? What's happening is you have one line on top of the other. So every point on there is a point of intersection. That's a dependent system. So if you end up with an always true statement with no variables, right? Because there's no letters left at this. X's and Y's are both gone. So if you end up with an always true statement with no variables, that's a dependent system. I suppose a colon would be better here. And right here. If you end up with an always, that's a dependent system with all points on the line as a solution. Oops, here. Dependent system, solution equals all points on the line. Because it's technically the same line for both of them. That's what makes it dependent. And that's what they say right here in this box. If you're talking about a dependent system, then, and the same thing would have happened with elimination. I just use substitution here. But when you use either substitution or elimination, you're going to end up with a true statement with no variables in it, like A equals A, 25 equals 25. And that solution means that it's dependent, so the solution is all the ordered pairs that are on that line. All the points on that line. All right, now we also want to be able to do this with a table, and I'm going to take some time here and do it with a graph as well, because I forgot to do this when I did this graphing stuff before. So you can see you want to solve 2x minus 5 equals negative 4x plus 13. And what you can do is you can use your calculator to help yourself. You can say, okay, I'm going to go to y equals, and I'm going to clear out my old junk. Right, clear, clear. Make sure your plot 1 is off. We don't want it on. And you're going to type 2x minus 5, enter, and negative 4x plus 13. Make sure you use the negative symbol, not the minus symbol. They're different. It should look like a little hyphen kind of a thing. All right, now I have an old window that's from some story problem, so I'm just going to do zoom 6. That'll make like a nice ordinary window. And if I can see the intersection on the screen, see it right there? That means you can find it with second, calc, pick number 5, intersect. Yes, y1 is my first curve, press enter. Yes, y2 is my second curve. It's hopped off the screen, but it's still there. Enter. For guess, you just want to move your cursor over here so you can see the blinky cursor is close to the intersection, press enter. And it'll find it. It's 3, 1. So that's what it is in a graph. Let me take a picture of it because I just wanted to show you guys how to do that with, oops, I forgot to copy that. Copy, paste. Okay, so that's what it is in a graph. We did it before with a model, but you could have used it for anything. Okay, so now we could also do it with a table, but hopefully you get what I was doing here. What I'm doing with y equals is I'm saying, look, let's make the one side of the equation 2x minus 5. That's y1. The other side is negative 4x plus 13. So when I find when they intersect, I'm really finding when they're equal to each other, more or less. We'll talk about it just a little bit more in a sec. So I'm going to go to the table, which is above your graph button. See the table right there? And I'm going to start typing down some of these numbers. So I'm going to take like negative 2, negative 1. I'm going to copy this table into this table down here on my paper. So let me pause and I will do that. Give me 1 second. There we are. I got them all in there. Okay, so those are, let me just highlight them ever so slightly so you can see. They are the numbers that are coming right out of my table. Negative 2 went with negative 9. Oops. Sorry, negative 2 went with negative 9 for y1, but with 21 for y2. See it right there? Negative 1 goes with negative 7 for y1 and 17, and so on. What I'm doing is I'm getting a table for 2x minus 5. That's this line that starts low and goes high. That's 2x minus 5. So it starts at negative 2, negative 9, goes up to negative 1, negative 7, and kind of works its way up and over, because it's got a slope of positive 2. So it's the increasing line. The decreasing line has a slope of negative 4. So it's off screen to start because it's at 13. And the screen only goes to 10 for the y max. And then it goes down 4 over 1, down 4 over 1. So it's working its way down. And the question is, when do they intersect? You didn't have to draw a graph of this. You can see they intersect right here. See how it's 3 negative, or means 3, 1 like that? So that means that they intersect, right? So the two lines intersect at 3, 1. Now that's not your solution though. What they wanted to know was, what is the solution to this equation that I gave you to start with? And I just kind of tweaked it to get the y's. But if you look at this original equation, what letter do you see in there? X, right? Nothing but x. So if I only want x as my answer, then I don't really want the whole point. All I really want to know is, where's the x where they intersect? So if you look 1, 2, 3 tick marks over and go up, that's where they intersect. So my answer is actually x equals 3, because they were only interested in the x value. That's your solution. So you use the points to help you figure it out, but we only really wanted this value over here, right? Like that. So again, nobody told you to do this, but I mean, if you use the calculator, you can really help yourself. And of course, the graphing part helps too, right? So you can use, you go to y equals, you type left-hand side of your equation on one side, the right-hand side on the other side. If you can get it so that the intersection's on the screen, then you can find it with second calc, number 5, enter, enter, and then kind of move your cursor and press enter. Boom, you find it. Or if it's a whole number answer, you can spot it in the table. But of course, the table this way only works for whole numbers, at least the way we currently have it set up. There are ways to play with that, but I don't feel like covering it in this particular video. Okay, so you can spot it in the table on the calculator right there. See where they're both equal to 1, right? So that means the x value of 3 is what you were really looking for, because that's where the two sides would be equal. And you could always check yourself. You could always take 3 and substitute it into both sides and see if it works. 2 times 3 is 6. 6 take away 5 is 1. Negative 4 times 3 is 12. Or negative 12, excuse me. Negative 12 plus 13 is 1. So it works. All right, we're all done with that section. See you back here for 3-3, more modeling, which means more story problems.